Thanks, Paul, for the introduction and having me over. I'm just a quick introduction of myself. I'm Nikhil Nanivadekar. I am originally from India, and my my academic education is I have a master's in mechanical engineering and with specialization in robotics. I joined Goldman Sachs in 2012 and started being a software programmer. Uh, July 2nd, 2012 was my first day at Goldman. July 3rd, 2012 was the first time I ever wrote a hello world program in Java. And now, starting last year, I am the project lead of Eclipse Collections. Well, I'm a co-project lead of Eclipse Collections. There are three of us, and we take turns in, taking responsibilities. What is Eclipse Collections? It is one of the collections framework which I'm going to look at today. It's essentially, it was formerly called as Goldman Sachs Collections or GS Collections. It was open sourced in 2012 by Goldman Sachs. It was migrated to the Eclipse Foundation in 2015 and rebranded as Eclipse Collections. Okay, with that, that's sort of my short introduction. I'm happy to chat more about myself afterwards, but I would want to cover more content, so to say. So, Paul suggested that I'll do two talks today. One is the collections compare. It's essentially comparing multiple collections, Java collections libraries. And the other one is how to get your project Java 9 compatible. And today is Java 10's birthday. So you need to first jump through 10 to through 9, then to 10. So I think it sort of fits well. All right. Did you plan it that way?
That's the first day of spring.
So, by the way, this talk was co-developed by three of us. That's Don Raab, he was the creator of Eclipse Collection. That Leo, then the next one is Leo Lima. He's a good friend of ours, and essentially the way it goes is he ends up writing an abstract and like comes up with this cool idea, and then submits it. It gets accepted, and now Don and I are on the hook to, get that going, and we pull him in as well again, saying that he got to do support. So he's a very good friend of ours, a very fun guy, one of the Java champions as well, and that's me. I already introduced myself. So how many of us have used Java collections, the whole collections framework? Yeah, pretty much. I see all the hands go up. Yes, that's right. Because collections are pretty much fundamental, one of the fundamentals of our day-to-day jobs, right? Of our normal code, so to say, that we end up writing. So how did we get here with the whole java.util collections? So it's the Java collection framework has been around for a while now, like about 20 years, and it's been there since JDK 1.2. It is very basic, but sort of a critical function. It started in 1.2 as a very basic implementation, but it pretty soon like gathered mainstream steam, and it became a foundation to all of our all the code that we write. It is implemented as interfaces with collections and maps, and like the interfaces can be list, set, deck, as well as the maps which are there are normal hash maps, which is the map implementation, or a linked hash map. Yeah, linked hash map, which is another type of a map. There are also concurrent implementations which are available, and they do support some basic algorithm. And starting with Java 8, it sort of like picked up more steam with the whole streams API, which is there. It's sort of like a tongue twister, steam. Okay, and the best way, if anybody wants to get started, like I'll be posting these. I'll send over this presentation to Paul, and all of those are the links wherever you see the hyperlink, so you can just navigate. They're available on like the World Wide Web for everything. So looking at a quick timeline, in 98 you got like the basic interfaces. In Java 5 was like from basic interfaces you went into generics. Like this was a very big jump in the whole Java landscape with the generics getting in there. And then the next big jump was at Java 8 with like the streams API. So you got the whole Lambda function, the Lambda style of programming, as well as the streams API, which is lazy, which creates a pipeline, and we're going to see some code about it today. In Java 9, there were some improvements in the collections framework, but not as drastic as like, or not, I wouldn't say drastic, not as much as the Java 8, changes which happened. But after all of this, I mean, I spoke a lot about the Java collections. How many of you use only Java collections in your code? Okay, just 3 people. So basically, we end up using other libraries which are there, right? And the reason for that is it ends up falling short, the Java collections frameworks which are there. So today we're going to compare these 4 different libraries with our plain old JDK. One is the Apache Commons collections, because that's been the longest around. In between, it did gather some fresh energy along with Java 8. Eclipse collections, as I introduced, I'm the project lead of the library. It was formerly called as JS Collections, and it is one of the top featured Java Collections libraries as well out there. And then Google Guava Collections, which I think is the most popular these days in terms of the popularity of the collections frameworks which are there. And a new up-and-coming contender called as Vavr. It was previously called as Java Slang. It came out, I think, in Germany. I think its maintainers are based out of Germany, and it's much more used for a functional style of programming, and we'll see what that means in a bit. So if we were to overlay the whole JDK's timeline on this collections timeline, then you can see in 98, you had Jakarta collections and Apache Commons collections. Java 6 got Google collections. That was the previous name of Guava. And then you had GS collections around 2012, because that time is when Goldman open sourced its internal collection framework for everyone to consume. And then with Java 8, you can see there's a lot more energy going on in the whole, lot more changes going on in the whole, external collections library sort of horizon, where you see there is Java Slang, which was the previous name of Vavr. Then there is Apache Commons collections, Eclipse collections, Guava, as well as multiple releases of each one. In 2017 with Java 9, so you can see as Java has picked up steam with Java 8, so has the other libraries which are there. Now, by the way, even though I'm a project lead of Eclipse collections, we have tried to be as agnostic as possible to the library. But apart from Eclipse collections, none of us are experts at any of the other libraries. So if you know that there is some other way of doing the iteration patterns that are shown, feel free to reach out separately. My Twitter handle, you can tweet to any one of us, and we will respond, and we'll be happy to improve the code that we're showing. Okay, so now coming to the actual topic, Collections.compare. When we are writing code, it's not just necessary to write just some code. You end up, as software developers, we end up making a very, very important decision when we decide to choose to use a certain library. Okay, let it be Guava, let it be this plain old JDK, let it be Eclipse collections, let it be Vavr, anything, because that becomes your legacy. So choosing any collections framework is very important, or choosing any aspect of your code is very important, because that becomes your legacy pretty soon. So we decided, this was actually Leo's idea, where he came up and said that he was a very strong user of Apache Commons collections, and Don and I were trying to convince him to start using Eclipse collection. And he was like, okay, let's compare how do these work, and that's how this talk was born. So looking at the whole domain, so to say, because then we had to come up with this idea of having a common domain with which we can explain the problem statement. So we chose the whole cards domain. How many of you have played cards? I like to keep my talks very interactive, so feel free to ask questions in between. I like it. So all of us have played cards. It's a standard, it's 52 cards. There are 13 suits and 13 ranks and 4 suits. Sorry, I flipped that around. So essentially, you have a deck of cards. It's made of an immutable list, and an immutable list is essentially which does not have the mutating API, so to say. You cannot add, you cannot remove. And the reason why you want it to be an immutable list is because at any given point of time, you only want 52 cards. Like, I mean, while playing the cards, yeah, they get jumbled, but still, the ideal deck of cards has 52 cards. Then you have an immutable list multimap. I'll explain what a multimap is in the next few slides, which is it. But and they're made of the card. The card is made of a suit and a rank. These are just two enums. The suits are basically a spades, diamonds, hearts. Ranks are ace, king, queen, etc. Okay. Any questions about the domain? All right. So we broke the problem down into three important parts. And those three parts were essentially to cover the most common iteration patterns that we as developers write. Okay. The very first one was we want to store a deck of cards in an immutable list. And in order to create that immutable list, you had to basically create a Cartesian product. You have to basically do a Cartesian product between enum and suit. Between rank and suit of those two enums which are there. Then you wanted to group the cards by, because it's like a group by is similar to the SQL group by, which is there. You're going to group them by the suit. And the next part of it was you want to count how many cards are there for each suit and how many cards are there for each rank. And then last but not the least, it was, you wanted to deal those cards. So essentially you wanted to get those cards out of that immutable list, so to say. Okay. I will go through the code, which will make it much more clear of what's going on, but just wanted to give you an overview. And feel free to ask questions in between. So the very first question, the very first problem, creating a deck of cards. Now you can see that we're going to step through each one of these, and I hope it's visible at the back. But essentially, the very first one is the JDK8 deck of cards, and you can see it's a list of cards. Okay, because JDK does not have an immutable list. JDK has an unmodifiable list. So essentially, it's a list with the mutating API already provided. However, if you try to add or remove, basically, if you try to mutate the list, it will throw at runtime. Okay. It does not have a multimap. It has a map. Now, explaining what a multimap is, it's essentially a map of a key, and the values is just not just one value, but it's a collection of values. In this case, it's a list of cards. That's the value. So essentially, for each suit, you can have a list of values. So consider it like doing a SQL-like function in a database where you're grouping by the suit. You end up getting all the cards which are there. Okay, that's pretty much what's happening. And this is called as a multi-set or a multi-map. Okay. The next one is Apache. The next one is Apache Commons deck of cards. Apache Commons does not have their own list implementation, so we fall back to the JDK8 list implementation. Okay. However, they do have their own multi-map, which is called as a multi-valued map. Okay. But the way you read this is essentially you have your key is suit, and then you have a collection of cards. Okay. Then Eclipse Collections, we do have both immutable lists as well as a multi-map, and we have a mutable multi-map as well as an immutable multi-map. So we are going to use the immutable list multi-map because we're trying to have the whole, the functional type of programming and the immutables and all of those things. The next one is similar to Eclipse Collections. Google Guava also has their own immutable list, and they also have their own immutable list multi-map. Lastly, Vavr. Vavr is interesting, where you see a list out here, but the list is essentially a Vavr list. It's not the JDK list. Okay, this map is a Vavr map. It's not a JDK map, and by default, Vavr is all immutable. Okay, it's placed to be a functional sort of. The library is written such that it will encourage you to do functional style of programming. Okay. So any questions so far in understanding the types? Because once you understand the types, the next presentation just goes smoothly. Yeah. This one? That's, sorry? So that's the Vavr. So basically, that's how their generics are. That's why. But in JDK, you get to create a list of cards. So essentially, because this is a map of, like, it's a Vavr map. So it depends on their generics. That's why you have to wildcard it, basically. Okay, moving on. The very first problem, to create a deck of cards and store it into an immutable list. There is some bit of common code for Cartesian product because it's those two enums, which is rank and suit. All you have to do is, do a Cartesian product of both of them. So we just abstracted this code out for everything except Eclipse collections. Essentially, you have nothing but, an enum set of all rank and suit. And then in the Cartesian product, you're doing a flat map and you're going over each of those elements and you're combining them. So it's fairly straightforward. Okay. Eclipse Collections has its own API called as Cartesian product. So you can pass in two sets. It will do the Cartesian product and return back. Now, you will find it interesting that here we are returning streams. Okay. And streams is by default lazy. Eclipse Collections by default is eager. However, we also have a way in which you can switch between lazy and eager. So that's why you will see this is lazy iterable. That's an Eclipse Collections interface, lazy iterable. And our Cartesian product is returning that lazy iterable. So you have the streams like functionality of laziness. Okay, up there. Next one. I mean, when we are comparing, we are not just comparing code, we're also comparing the benchmarks. So the first one is the performance benchmarks. How many of you have heard of JMH? Java Micro Harness. So a couple of people. Essentially, Java Micro Harness, it's an open JDK product where it will let you test out the performance of your particular code. What it will, like, it ends up reporting measures in terms of operations per second or time per operation. Like, there are like 4 or 5 different ways in which it can measure. There are 4 or 5 different ways in which you can run it. Okay. We are running it such that the measures reported are operations per second. So essentially, higher number the better, because that means you're performing more operations in 1 second. Okay. A part of performance testing is you have to keep your hardware, like, your performance is very hardware dependent. So we try to keep it consistent. It's run on my laptop, which is an Intel 4-core i7 with 50 warm-up iterations, because you want to warm up your JVM so that you get consistent performance. And it has 30 measurement iterations across 3 forks. So essentially, these measurements are averaged across 90 iterations. Okay. The next one, which we're going to look at, the memory test, because I mean, at the end of the day, you also need to make sure that, like, you have a high performance system, but you're not losing time in your garbage collection or anything. Your memory footprint is, like, smaller, as small as possible. So we are going to be using object size calculator, which is an internal class in Java 8, and that's partly one of the reasons why we are not comparing Java 9 collections. We are comparing Java 8, because as a part of Java 9, this object size calculator class, which was there, it was made internal, and so it's no longer available for public as a public API. It's a part of Nashon as well, so that's why we're sticking to Java 8. Eventually, now with Java 10 out, we will end up moving from Java 8 to 9 in this presentation. In memory tests, contrary to Java micro benchmark tests, JMH tests, sorry, smaller numbers are better because you don't have as small of a footprint as possible. Okay, one more disclaimer out here. All of these measures, especially for JMH tests, they are, like, we're talking about, like, millions of operations per second. So don't, like, even if, like, Eclipse Collections is higher than Guava, or Guava is higher than Eclipse Collections, or all of them are, like, higher than the JDK, or vice versa, like, don't take it for it. Your mileage may vary. You got to measure your system's performance. That is one. Second one is, like, in a big system, like, this small difference which is there, unless until it's, like, separated by an order of magnitude, I don't think it makes much of a difference. But that's my opinion. So please take it with a grain of salt. I don't want to have like, Twitter buzzing saying that Nikhil said. So, all right. I normally like to show the performance before showing the code so that you understand why exactly the performance is the way, the way you can see the graphs. So essentially you can see, and these colors we have tried to keep it consistent. It goes in an alphabetical order from left to right. It's Apache, Eclipse Collections, Guava, JDK, and Vavr. Now you'll see the Eclipse Collections in the Immutable list, which is there. It has a slight edge. I mean, it literally has an edge of 20,000, like over 200,000. So it's not a very big edge, so to say, but it is the fastest. But if you look at the memory footprint of them, you will see that Eclipse Collections and Guava, both of them, they consume the least amount of memory which is there. And both of them consume the exact same memory. Okay. Now we'll see why. Any questions so far? Okay. This is the code for JDK. Zooming in, you will see that JDK does not have an immutable list the way I mentioned before. It has an unmodifiable list. Essentially what that means is the mutating API is exposed, but it will throw at runtime. All right. Now a few things happen when you take a list to be an unmodifiable versus immutable. An unmodifiable list does not get compressed. So imagine this: when you end up creating an array list, okay, when it gets initialized, you will have 10 elements, right? All of us know that. But let's say you end up occupying only 2 elements. You convert it to an unmodifiable list. The rest 8 slots still remain, okay? But if you end up converting to an immutable list, the 8 slots, they get trimmed, okay? And Eclipse Collections has specialized. So we actually did some benchmarking where we figured out that, hey, it's faster to go on an element by element. So essentially we have, singleton list, doubleton list, tripleton list, dot, 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 like that on the immutable side. Because what we said was you can essentially, instead of having an array, you can just have that element. And then the equals becomes faster, the contains, like basically all the operations become faster, and the memory footprint is smaller as well. So there are a few optimizations which most libraries end up doing. But however, since you're using an unmodifiable list, it never gets compressed. That's why you see the memory footprint, which is out here, okay, for the JDK. And one cool thing to see is like the JDK and Apache are almost similar. And the reason for that is they share the exact same code because Apache does not have their own list. Okay. Any questions? So that's why like whatever properties you see in the JDK is exactly mirrored on the Apache common side. All right. Now looking at, sorry, go ahead. For Apache Commons, the unmodifiable collection. So I think last Java 1, there was a talk given by one of the, I forgot the name, but where they were talking about what exact immutability means. So it's not that they have completely discounted like adding immutable collection. I think it's in the thought process, but I don't think it's there as yet. So I hope that answers the question. Any other question? Okay, moving, and I think that talk is available on YouTube. So, okay, moving on. So Eclipse Collections, we have our own immutable list, and you can see it's essentially you're getting the card and you're getting the Cartesian product, and then you create a 2 immutable list. Now, the 2 immutable list which is there, it ends up returning an immutable list for you. However, you can see that there's one more operation that we are doing here. You're sorting those cards. Okay, so here, when you're looking at the operations which are happening, this is an ON operation, okay, and this is another ON operation, which is there. So you're executing 2 ON operations. So that does come, into picture while you're looking at the JMH benchmarks. However, if you see the JDK out here the sort and then collect, which is there, that's happening basically. So let's say I remove the 2 sorted list out of Eclipse Collections, I would presume that it will perform much better than the JDK. Okay. The next one is Google Guava, similar to that. So Guava is very interesting because they have their own collectors. Okay. So does Eclipse Collections. However, they have their own immutable list collector. Okay. Now this is card.stream of cards. So it's getting a stream. You're sorting the stream, and then you're collecting into an immutable list, which is the Guava immutable list. Okay. Does this make sense? You're a very quiet group. And Vavr, like I said, by default is always immutable. And this list is the Vavr list, and it's the list.collect. These are all provided by each individual library which is there. For example, going back to what I said about Eclipse collection, we also have our own collectors which are there. However, we believe in having the API on the collection itself. So each of our collections will have the entire API, which is there. So you can do a .collect, .select, .detect, etc., etc. And if you want to do it in a lazy way, you just do .asLazy, and you can do a .collect, .select, .detect. Okay, yeah. Rank. So the card which is there, by default, you can sort it. It is comparable. So it has a comparator on there. So right now, we're sorting it by the rank. Yeah. But that's pretty much it. The reason why we added the dot sorted out there is because, having one more operations out there. Like it does not sort of change the way the code is going to look other than having one more line out there. And it also makes the performance benchmarks interesting. This one? No, each one of them is the same, and that's the one which I had showed at the start. So stream cuts. All the libraries except Eclipse Collection share the same code. Yeah, we have tried to be as fair as possible to every library, because at the end of the day, we do face these problems pretty much on a daily basis to see, hey, which library should I use, or should I just fall back to the JDK? And most of the times we end up doing that, right? So that's why, we have tried to be, like I said, even though I own Eclipse Collections, as a project lead, I'm not trying to be I'm not trying to have favoritism towards it. I will appreciate stars on my repository. But I think I'll make those announcements after the first break, which is it. Okay, all right, moving on. So the next part is group the cards. Sorry, that was not. So group the cards by suit. Okay, and looking at the performance, you can see now here is the very interesting thing. JDK blazes through, right? It completely blazes through, and it's nothing but a map of key and a collection of values. All right. And the reason, I'm going to tell you why it blazes through in a minute when we look at the code. But you can see the other contenders which are there, like Eclipse Collections and Guava, they're almost there. But I mean, if you're looking at this only chart, I will end up using JDK as well. Okay. But if you compare it to the memory benchmark part of it, you will see that JDK ends up being the fastest, as well as being at par in terms of memory. Vavr ends up using the most amount of memory out there. Now, why do you think that's this? You see JDK blazing through? Anyone? Sorry? The read operation? No. So the interesting thing is, remember, it is a mutable list multimap. Okay, JDK does not have an immutable list. Now, the definition of an immutable list multimap is the multimap has to be immutable, and the individual collections also have to be immutable. That ends up increasing the big O complexity. Now, if you look at the JDK code out here, it's very difficult to understand. I'll take you guys through. What's happening here essentially is, first, you end up grouping the collectors by suit. Okay. And then you're streaming that in there. And then you say that, all right, now that I've gotten all the list of cards for this particular suit, wrap it around an unmodifiable list. Okay, creating an unmodifiable list is an O1 operation, whereas creating an immutable list is an ON operation because it does a copy over. And then once you're done grouping everything, you end up adding it to an unmodifiable map, okay, which is another O1 operation, which is there. So making an unmodifiable map is O1, okay, but actually constructing the map which is there, that is still ON, okay. Does that make sense? So basically, you're back to just having one ON operation here, okay. However, if you compare it to Apache, here the interesting thing becomes is similar to our previous problem of Apache not having not having their own list implementations. However, they have their own multi-map implementations which are there, and they give you an unmodifiable multi-value map. Again, so this is just one ON operation out here. Okay, and here essentially what it does is it goes through your stream of cards, and it ends up getting the suit and just groups by the suit. Fairly straightforward. And then moving on to Eclipse collections, it's a one line of code. Okay. Now that one line of code is a group by operation which is there. It's essentially equivalent to your SQL group by. Now Eclipse collections has something called as covariant overrides. So if you end up doing an operation over a particular iterable, a rich iterable of Eclipse collections, we will end up returning the same type or the most equivalent type for that. Now what that means is, since cards is an immutable list, when you do a group by on cards, it ends up returning you an immutable list multimap. That's why you're not seeing here any calls to two immutable. Okay. However, it ends up returning a two immutable list. It ends up returning an immutable list multimap. Okay. Now that becomes important because that way users don't have to worry about what am I going to get back. And we have given enough overrides so that if you want something else, you can definitely get it. Okay. Any questions so far? Yeah. The next one is Google Guava. And similar to Eclipse collections, Google Guava also is like a one line of code. The difference is it has a factory method called as multimaps. And in multimaps, it essentially says, okay, take your immutable list and group it by the suit. For some methods, Guava also has covariant overrides. And because this dot cards is an immutable list, it is returning back an immutable list multimap. Okay. So far, so good. Okay. Next one, Vavr, similar to Eclipse collections. It's also one line where you do a group by. Now the interesting thing is the cards is a Vavr list. The group by returns a Vavr map, a Vavr multimap, so to say, but it's a map of like a key and the wildcard list of values. Okay. Now putting all of this together, this is how the performance looks, including immutable list and group by. What does that tell you? In order to, if you end up running both of these operations together, essentially your deck of cards which is there, it's comparable for all the libraries, right? Now, the reason why it's comparable, even though JDK blazes throughout here, like it's the clear winner. However, for other operations, the iterations are faster for other libraries. So they sort of make up, okay? This is much more of an interesting graph according to me, where the memory footprint which is there, you can see that these are all comparable. However, Vavr shoots off the roof because of its immutable nature. So the whole concept of immutable is anytime you're trying to add something, it's like a string. You can't just append it. You end up creating a whole new structure, right? Whenever you're trying to append or add to it. Okay. The next, how am I doing on time? Yeah. Yeah. Mm-hmm. Yes. No, we keep it in the same order. We keep it in the same order. While dealing the cards, we shuffle. So while doing the group by, they're in the same order, but the order is exactly the same for each and every of those libraries. Is that? Maybe, but and most likely because of the way, you know, where it gets to essentially put in that map, which is it. So most likely yes. The next one is countsBySuit. So essentially, how many of you have had to write code where you have a map of a key and just a counter? Like let's say how many users logged into my, you know, UI, right? Most of us have that, where you have a map and like let's say a key is a string, for example, and then you have a counter which you keep on incrementing every day. Now that data structure is called as a bag or a multi-set. Okay, bag it's called bag in Eclipse Collections and Guava. It's called as a multi-set in Apache Commons. Okay, and this is the comparison for that bag data structure, where you can see Eclipse Collections. It's the fastest performing. Again, however, it's not like as blazing fast as it was like, you know, in the other one. Here you will see it's sort of comparable because you're looking at approximately 1.7 million operations per second. Okay, so it's comparable. In terms of memory, though, it ends up using the least, and the reason for that is Eclipse Collections has a bag data structure which is backed up by a primitive map. It's an object primitive map. So Eclipse Collections has a whole, you know, hierarchy of primitive collections. So we have our int sets, int, long, short, all the 7 primitives which are there. So int, long, short, byte, boolean, and which one am I missing? Char, and there's one more. I said by, yeah. Yeah, I didn't say so. But anyways, so all the 7 primitives which are there, they are already available, and you have lists. Like I find it funny when like everybody's counting. It's like, you know, how you name all the 50 states of the United States. We're only talking about that, but essentially, so it's backed up by a primitive map, which is there. And since it's backed up by a primitive map, we don't end up boxing that integer, and that ends up saving the memory. Also, that's why it becomes faster. Counts by rank, and you can see that how many ranks are there? How many ranks are there? 13 ranks, and there are 4 suits. So that's why you will see that the difference in numbers is obvious because you have more elements in rank. Okay. Memory tests, again, the numbers are, you know, higher. However, the pattern is the same. Okay, between the libraries. Now, how does the code look like? It's essentially doing the same thing. So I'm only going to take you through the first one. Only the grouping, this one changes, the method changes. So here you get the stream of cards, and then you end up using the grouping by collector, which is there, and you count it. So essentially, what internally happens is, while you're iterating through this card, it ends up checking, hey, do I have the same suit? Yes, I have. I'll increment the counter. That's what's happening. And same thing for rank. Apache Commons, it has, and here's the interesting thing about Apache Commons. It has a bag as well as it has a multi-set. Essentially, both of them are the exact same data structure. Okay, I do not know why both of them were added because I'm not on the, like, I'm not a maintainer for the library nor a contributor. However, both of them are present. Maybe there were some reasons behind it. But essentially what's happening here is you're mapping them to the suit, and then it's hashbag is their bag implementation, which is there, or a hash multi-set, which is their multi-set implementation, which is there. Essentially, this data structure is giving you the suit and the number of, you know, cards it has for that suit. Okay, fairly straightforward. Eclipse Collections, we have a countBy method, which is there. And the interesting story about the countBy API is, after writing this talk, we had like a few people come up, as well as we as maintainers, we realized, how come we don't have a countBy API? because all you had to do was go it in lazy uh, and get it to a bag. That's it. It was very straightforward. So if you look, it's implemented as a default method, a count by. But essentially, you're counting by the suit, and that gives you a bag, which is the Eclipse collections bag. Uh, Google Guava, which is there, they have their own collectors, which are here. So now here's an interesting thing about Google Guava. So what this is saying is, each time you see the suit, increment it by 1. Okay, that's this function, e lambda 1. Okay, and this is their factory method. Okay. Vavr, similar to all the other ones, like it does have their own collectors as well, and this collectors are counting. Now the interesting thing is they don't have their own bag, so they're giving back a map. It's a JDK map. You see, the java.util map. Okay, so that's what's happening for a while. Last of this problem statement. Now you have a deck of cards. You got to be, when you're playing cards, you got to deal them, right? Now we are going to deal five cards to 5 people, or 5 hands of 5 cards. Okay, and we will be shuffling those cards before dealing. Okay, and looking at the performance, again, Eclipse Collections wins, but and here the win is not just marginal; it's pretty substantial out here, because it's 1.3 million versus like the closest one is 935K. Okay. The memory also, it has the smallest memory footprint out here. Okay. For JDK collections, now here is, so you're getting 0 to hands. In our case, there are 5 hands, so it's 0 to 5, and then you're dealing the shuffled cards, the shuffled deck of cards, because like you normally want to stack and you just want to go on popping 5 cards, right? And the advised implementation of stack is the deck, which JDK does, because deck is the one which is first and last out, or last and first out. Right? You have a stack of cards and just work. For Apache collections, it's similar. It's pretty much exact same code as the JDK, but you're using the list utils, which is coming out of the Apache Commons collection. For Eclipse collections, you're essentially giving, again, you're going 1 to the number of hands, so 1 to 5, and then you're collecting, and the this.deal, which is there, it's nothing but like just popping it off the stack. Okay. Google Guava, again, similar to all the other ones, they have their own API. It's doing its job. The most interesting, like, mind bender is Vavr. Okay, who can explain this code and like looking at it in one shot? Okay, I see some frowny faces. Okay, it's fine. I'll explain. it did take me like a few. I think it took me like about half an hour to actually understand with my debugger to see what exactly is going on, because it's not that straightforward. And again, it's not just the performance, it's not just the immutability aspect of it. You also have to look at the code maintenance aspect of things, right? Now, the reason why it ends up becoming in this way is because Vavr by default is immutable, okay? Each time you're popping something off the Vavr stack, it is going to give you a pair. The pair is what you popped and what remains, right? Does that make sense? Now, because of that, you end up getting this _1, which is what you popped, and you get this _2, what remains. And then you keep on just resetting whatever remains in the shuffle, and you keep on appending to the Vavr list of whatever you popped. So that's all that's happening. But in order to get like such a simple feature, you do have to write that convoluted code. Okay. Any questions so far before I go on the last slide? Okay. So this is the last slide. So what we did was we said, okay, fine. Now we have this one problem statement which is there, but people like to have a scorecard, right? Which this was actually done mostly by Don, and he went through every library and tried to figure out what all things are available in that particular library. And that sort of gives you this one, scorecard which is there. The solid greens are, it's there, it's supported, it's implemented. The solid reds are, it's not there at all. Okay. The box greens are, it is there, it's almost there, but not completely there. There's still some more work. Um, the box reds are, it's not there as yet. Okay, it's like that. So what does this like whole table tell you? It depends on your use case what you want to use. Now, for example, if you need a table, the only library which gives you a table is Guava. And interestingly, there's an open issue in Eclipse Collections where like a user, I think it was a couple of weeks ago, last week, where they said that, can we have table in Eclipse Collections? And we're like, we are fine if you like, we would love to have table, feel free to contribute, right? Because that's something which they, and then they wanted to add primitive tables. Now the interesting thing about primitive tables, which we end up dealing with at primitive maps in Eclipse Collection, is because you end up getting those permutations combinations, right? Because for each primitive key, you can have 7 primitive values. So it becomes 7P7, or rather 7C2. That becomes your number of implementations that happen. Because an int can have an int key and an int value. An int can have an int key and a long value, a short value, a byte value, a Boolean value, right? A char value, right? So all those 7 which are there. And that ends up exploding the library by a lot. Now, a table is essentially where you have the key and a row. So essentially you have a column and a row. Now that will end up becoming a primitive key, then a primitive key of another key. So it will just go on and it will explode the library. So we said, we're fine you adding a table, but we can only take it on the object side. So that was one. The second aspect now, if you see, if you want additional types, you have JDK, Apache, and Guava. Okay, those additional types, like for example, are the linked list, a linked hash map, a linked hash set. Okay, now if you look at a bimap, only these 3 have a bimap. So bimap is a bidirectional map where you get like looking up in a map using a key is O1, but looking it up using a value can be ON. Okay. However, a bidirectional map is where even looking up through the value becomes O1. Okay, because it's essential. So think about it this way: like it's a map of key to value and a value to key. Okay, so only unique combinations can exist. So if you need that, these 3 give it. Okay, if you want immutable, your only option is Guava, Eclipse, and Vavr, right? Like JDK, you can get unmodifiable, and presumably in the future, you can get an immutable. If you want a fluent API, when I say fluent, we mean the functional state API, which is that where like the whole API is on the collection itself. Like you don't have to dot stream and a pipeline or something like that, or you don't want to use static methods, but it's directly on the iterable itself. If you want to do that, if you want to do functional style programming, you can use Eclipse Collections or Vavr. Okay, of course you can use streams as well, but it's not again directly on the iterable. Okay, all of this code that I showed is available on my GitHub repo. Again, I'm going to be circulating these slides to Paul, and he'll make it available to all of you. So if you find any code which could be improved, because this happened at DevNexus last month, or the month, like in February, this happened, which was last month, right? Yeah. Sorry, it's like all over the place. So yeah, in February it happened where someone came up and said that no, you can improve this code for Guava, and we're like, okay, let's meet afterwards. We worked on it and we saw, yeah, you can really improve it. And that's the beauty of like, open source. Now again, like the thing about this talk was, like I said, I tried to be as agnostic as possible to explain the nuances of each library. Each library maintainers, and me being one of them, like I know that they end up spending a lot of their personal time, a lot of like, a lot of their extra time, so to say, to maintain an open source library. So by no way I'm trying to say that, hey, their library is bad. No, I'm not saying that. All these libraries, your mileage may vary. You got to test that out. It depends what your use case is. Okay? And any questions? I think we have, are we already over time? Yeah. So if I have to give a rule of thumb, which I give to my team, because I own Eclipse Collections, I ask them to use Eclipse Collections. So, however, I can't give that exact same, a cookie cutter approach to all of you. But everyone who, yes, you have to performance. Also, it depends on your use case, right? Like for example, if somebody really needs a table in JDK, you don't have any other option but to use Guava, right? Or use a real table, or use a real database table, right? Like, so it's like I always like to give the table example because Guava is the only one who has that. Now, if you look at like Guava is like it's a sort of a kitchen sink library. It does not only have collections; it has other things as well. If you look at Eclipse collections, it's pretty much a supplement to the JDK collections. So, like our list implementation, they have mutable list, mutable set, mutable map. Okay, sorry, those are our list interfaces. But each of them, they extend the JDK interfaces, except for stack, because our stack is first in, last out, or last in, first out, right? So, however, all of these implementations are a drop-in replacement. So, wherever you have a JDK list, you can just pass in a mutable list, okay? And after the break, I'll actually share some links about Eclipse Collections, which is there. And like there are a few laptop stickers as well. I think we have kept some outside if you want to grab. But again, like I'm saying, for me to give like a cookie cutter approach to say that no, you have to use this. Like for example, if you're working with serialization and deserialization, and all you're doing is getting a list, doing something, and pushing it back, you don't even need an external library. JDK works fine. Like I mean, it's good at what it does, right? So that's why I said like it really depends. And again, most of the times what ends up happening is we end up coming like yesterday itself. I answered a Stack Overflow post where someone wanted to actually remove elements from a set depending. No, they wanted to do a set difference depending on only one method in that object which is there. And so Eclipse Collections has specialized types called as sets with hashing strategy as well as map with hashing strategy. What a hashing strategy means is, let's say a person object which has a first name and a last name. You don't want to use the equals and hash codes of the whole object that is equals and hash code of person and first name and last name. Let's say you only care about uniqueness using the last name, right? There is no way in JDK for you to override that other than probably create a comparator or probably override the whole hash code of that whole object itself. However, in Eclipse Collections, you can pass in a hashing strategy, which basically says that, okay, get me the uniques only using the last name. And I can show you my Stack Overflow answer and we can discuss more afterwards if you want. But essentially, that's the reason for it. Like now, I end up using hashing strategies a lot because I can also do a get on a set. Now, this is where people are like, what Nikhil is doing with get on a set. Yes, because the Eclipse Collections set ends up extending pool, which has a get method. Now, what that allows me to do is I can actually construct a set similar to a map. How many times have we created a map where you have a key, okay, which is let's say a last name, and then you have an object which is the whole person object. Most of us do that, right? But we can end up, completely reducing the whole overhead of creating a map by just creating a hashing strategy set, because now you can do a get using the whole person object, and it will only get it using the last name, and that ends up saving a lot of memory. It ends up saving a lot of garbage collection. It ends up saving basically unnecessary processing cycles, which are there. I can go on talking literally forever about this. That and robots and other stuff. So, but we should. Sorry, last question, then we'll break. Okay, good point. That we can definitely add. And regarding Android developers, like Eclipse Collections does come into that very weird bracket because our library is pretty big, and the reason for it is the primitive maps which are there. Like I told, right? It's a 7C2, and it ends up inflating, and we code generate. So we have templates, and it will code generate all the classes for us. But that causes issues, especially for Android developers. And in the past, users have actually used ProGuard to strip out the library and reduce the size. So we have had users do that, and we didn't know that there were these limitations and everything because you're working on a different scale. Now with JDK 9, one of my because of the modular system, and we'll be looking at it soon. Uh, because of the modular system, I actually want to create the whole primitive maps which are there as a separate module that will end up reducing the size of the library. Like I want to get it to a certain level where I can actually segregate the whole primitive side itself into a separate module. And then that way my footprint is smaller. But that's TBD once I get time. I think we should break for like 10 minutes.
Let's go. Break for the 10 and we'll